Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Today, inshallah, shabab, we will start chapter P. The letter P here, it stands for prerequisites, which means that the concepts or the issues that you need to know before you start. We will start with section P2, the real numbers. In fact, I put most of the load on this section. You can find that, for example, here that we have like 115 slides. About like 40 slides are about the topics, the examples, the concepts, the rules, the definitions. But the others, like 60 to 70 slides, are all the exams to practice and solve. So it is like the half of this chapter. What we are supposed to do in this class, in fact, we were supposed to start with solving these exercises. Look at them here. We are supposed to start with these exercises. If x is, if y is, if w is, then what is x plus y? If you look at them, we have here a fraction, rational number. We have here integer. We have here a fraction. We need to add them, to divide them, to square it, and so on. Also here, how to find the exact value of the addition and subtraction of decimal numbers. But as I told you, Shabab, this is not the right way to do mathematics. To do mathematics, don't start by the exercise. You should start with what? Idea. With the concept. What is this? How to do things, and then practice. So what I'll do in at the beginning of chapter B, I will start with reminding you about many mathematical terminologies and expressions, what they are, how to convert them from your knowledge in Arabic to English. So this is section P2. It is about the real numbers. We will see together, after finishing this section, you will be able, inshallah, to classify the real numbers, which means that you will know, are they integers, natural number, rational, irrational, and so on. You will be able, inshallah, also to use properties of real numbers, to work with fractions. This is so important, to sketch the graphs of numbers on the numbers line, to use the ordered symbols, less than, greater than, to work with sets and intervals, especially intervals, and how to work with absolute value. This is very important. We will do it, inshallah, maybe next week, by the way. We may spend 2 weeks on this section, because it is the foundation of the course. So, you know, when you build a house, you spend some time building the foundation. After that, it will be, inshallah, so easy to continue. Finally, we will be able, inshallah, to learn how to find the distance between numbers. What I prefer also to start with is this list of mathematical expressions, how to read this. But also, I don't like you to just memorize them. So you will spend like, let's say 10 to 20 minutes on this. How to read this, the first one. A plus B is equal to or equals. You can use is equal to or equals as you want. Is equal to C. What we are doing here, this operation, it is called addition. The result of addition, it is called the sum. I will mention this later for you one by one. It is, I think, better than listing them here as a table. You can continue, of course, here the subtraction, the multiplication, the addition. It is good to know. And as I told you, Shabab, try to understand it mathematically. What is it? No need to translate to Arabic. It will be better to go from math to English or from English to math. You need to mainly understand it mathematically. What is it? Let me start with the real numbers, okay? The story of numbers. Do you know the story of numbers? How the numbers developed from the beginning until the end. But before that, let me ask you something that I need to clarify at the beginning. Because we are in algebra course. In algebra, we mostly use, ya shabab, letters to express numbers. So when I write, for example, when I write A, what comes to your mind? This is A or X or whatever. This is A. Unknown. A, since we are in a math class, it is unknown. Of course, it is an English letter, the first English letter, A. So A, when we think about A, we think about something that is unknown, something that could be what? Anything, any number, anything. It is more general. Let's say, since we are talking about numbers, it could be any number. What you can understand about this number? Is it real number, integer, rational, irrational, positive, negative? We don't know. When we just write it like that, of course, we will say it. But if I said A is greater than 0, what you will understand from that? Positive number. It is a positive number. If I said A belongs, this means belongs, is in R. If you know what is R. R here, it means the real number. You will understand that I mean a real number. Okay, good. So now if I write a shabab here, negative A. This is sign. Sign, we have two signs, shabab, negative and positive. These are the signs that we have. So when we write negative A, what you will understand? Is this negative? Is this positive? The answer is no. Is this negative? The answer is no. It depends on the value of A. But if I write this 3, positive or negative? Negative 3. So now look, if A is 3, what will be negative A? If A is 3, negative A will be what? Negative 3. So this will be negative, this will be positive. But if A is negative 3, what will be A? What will be negative A? Negative A will be negative of negative 3. It will be 3. So this is positive, this is negative. So what we want, ya shabab, when we say now A plus B, A minus B, here we mean of course real numbers for this context. Now, I think we are ready. What I was planning to tell you, shabab, when you have a symbol like this, don't think that this is positive. It could be positive, it could be negative, it depends, unless it is mentioned. Great. So the story of numbers, shabab, start when the first human beings start counting. So they have one son, 2 sons, 3 sons. So they use the counting numbers. So this is why they call it natural numbers. They came from the nature. It is natural to think like that. Okay. Now, of course, they are infinitely many because you can keep counting forever. We can classify the natural numbers into 2 types or 2 types of numbers: prime numbers and not prime numbers. What is the prime number? Prime number is a natural number greater than 1, bigger than 1, more than 1, that has no positive divisor or factors. What we mean by divisors or factors? Let me give you an example. It will be easier. I will mention this later, by the way, but let me just give you an example. 3 times 7. 3 times 7 equals to what? These 2 numbers, 3 and 7, they are called factors. They are the factors of 21. The factors of 21 are 3 and 7. Okay, and the same word, divisors. Okay, now the prime number is a natural number greater than 1 that has no positive divisor or factor other than 1 and itself. Like what? Like 2, 3, 5, 7, 11, 17, and so on. 17, think about 17 is what times what? You cannot find any other numbers other than 1 and 17. So these are prime numbers. What do you think? Is 1 a prime number? No, it is not. 1 is not a prime number, because we use it to define the prime numbers. And we said here that is greater than what? greater than 1. Good. Now the numbers, ya shabab, the remaining, these are these all the natural numbers? No. The remaining ones other than 1, they are called the composite numbers. What is the composite number? It is the number that is not prime and not 1, of course. Like what? 4, starting from 4. So the composite numbers starting from 4. Excellent. Do you know, ya shabab, what is the fundamental theorem of arithmetic? In any subject, ya shabab, there is something that is called the fundamental theorem of arithmetic, the fundamental theorem of algebra. We will study the fundamental theorem of algebra in chapter 3, inshallah. When you study calculus, you will study something that is called the fundamental theorem of calculus. In every subject, you will find a fundamental theorem, which means that is the most important one. The fundamental theorem of arithmetic, النظرية الأساسية في الحساب. إيش هي؟ The fundamental theorem of arithmetic says every natural number can be written as a product of prime numbers. Give me any number, it is a product of prime numbers. Okay, so of course this is the idea that used to factor. For example, if you have 100, it's enough to have 100. What is 100? Simplify it and write it as a product of prime factors. What is 100?
10 times 5 squared.
10?
10 squared, 10 times 10.
10 times 10, but 10 is not a prime number.
5 squared times.
It is 2 times 2 times 5 times 5. Now we expand 100 to its original components. So this, like, you return it to its original starting. And this is what the best way to deal with numbers is, to write them as a product of prime numbers. It will be after that so easy for you to simplify them, to deal with them, so easy. Good. Now, it is not enough, ya shabab. They were thinking that these are the natural numbers, are all the numbers, but they are not indeed. Let's say, for example, one, he has a kid or an animal and it has died. So he has no sons, no kids. So he has nothing. So how to express that? We need to add 0. Okay. And in my opinion, the best way is to use the closeness idea or the algebra, the equations idea, to know why we need more numbers. Why? Let's start with the closeness. What I mean by that is, this set is enough. I can do all the operations or not. For example, think about 1, 2, 3, 4, 5. If I add 2 natural numbers, are we going to have a natural number? Add 1, 2, 3, 4, 5. If you add any number, any natural number to any natural number, we will get natural number. But if we subtract 2 minus 3, 2 minus 2 is not a natural number. We need to add 0 because of that. We need also, if we subtract 2 from 3, we cannot put it in this way. So we need also the negative number. So what we need to extend these numbers to more numbers. So we have here the integers. No need to say numbers when we say integers, because enough integers. And if you translate this into Arabic, you know that it means the correct numbers. They were thinking, oh my God, this is the correct, these are the correct numbers, not the previous ones. But indeed, we will see that they are not, of course, the only numbers that we need. So what they did, ya shabab, they add the 0, which is the difference between when you have something and you lost everything. So this is when you have nothing. Now the negative numbers, in fact, also they are not invented them for fun. They exist in the real life. When we have some places that they are above the sea level, and some places they are below the sea level, and the sea level is the 0. In the temperatures, when they have a thermometer for the temperature, they notice that the thermometer is going below the 0. So there is something below the 0, and these are the negative of the natural numbers. So 1, -1, 2, -2, 3, -3. Now these are called integers. Okay. So 1, 2, 3, which they are the natural numbers, we will call them positive integers. And these are the negative integers. And we have also non-negative integers. What are the non-negative integers? The positive and 0. So look at the difference between positive and non-negative. Because you know the 0 is signless. The 0, you cannot say that it is positive. It has no sign. There is another name, ya shabab, for the non-negative integers. What is it? The another name for non-negative integers is the whole numbers. When they add 0, by the way, they were thinking, oh, these are the all numbers that we need. Now, let's go back to the need, why we need to extend the numbers more and more and more. But let me explain that after this. The integers can be classified into 2 types also, even and odd. We have even numbers and odd numbers. These are integers, by the way. So any integer that can be divided exactly by 2, what we mean by can be divided exactly by 2, like for example, when you have 64, when you divide it by 2, what you have? It is 32. When you multiply, you will get 64, and the remainder is 0 when you subtract. So this, the meaning of divided exactly by 0. There is no remainder. The remainder is 0. And these numbers are what? Are the multiples of 2. 2, 4, 6. Go to the left. 2, 0, -2, -4, -6, and so on. Okay. And the remaining numbers, after removing all the even numbers, the remaining numbers are called odd. What are the odd numbers? 1, 3, 5, 7, -1, -3, -5, and so on. Okay. Now, you can ask yourself, when we add 2 even numbers, what we are going to have, even or odd? When we subtract, when we multiply, when we divide, think about these issues. This is good for you to practice. Now, what else? What else? Before going to the rational numbers, let me show you the need. Why we need is this? These numbers are not enough to do all the operations. Let me give you, for example, here. Look at these integers. If we add or subtract or multiply any of these numbers, we will get one of them. The product and the sum and the difference between any 2 integers is also integer. But what about the division? When we divide the division, when we divide 6 over 3, what is 6 over 3? So integer over integer, it is integer here. It's okay. But what about 3 over 6? It is a half. So when you have 3 bananas and 6 people, you need to give them, one of them is half. So this one is not here. It is not an integer. We need to extend it to another set. So this set that we need to extend to, it is called the rational number. What is the rational number? Rational, it comes from ratio. Ratio, it means when you have a ratio between, this is a ratio, m over n. So what is the rational number? This is so important, ya shabab, here. What is the rational number? The rational number, when you have integer over integer, this is a rational number. Okay? Like what? Like 1 over 2, a half. -3 over 7 or 3 over -7. 8. It is 8 over 1. 8 is what? Is integer. But also it is what? Rational, because every integer is what? Rational. Just put the denominator equals to what? To 1. So if you have 3 or -3, let's say, -3, it is -3 over 1. So it is also integer over integer. We can conclude from that every integer is what? But the opposite is not true. Also here, look ya shabab, 0.13. It is 13 over 100. This is integer over integer. Okay. Now, is that enough ya shabab? Let's see. Let me show you something. Now, why we need to do that in terms of algebra and equations? Let me see. X plus 1 equals to 2. What is X? It is natural number, no need. The natural numbers are enough. But if we said x plus 1 equals to 1, x is 0. So here, this is not a natural number, this is integer. Now, when we say x plus 1 equals to 0, x is negative 1. Now, we're still talking about integers. Okay. Now, when we say x, let's say 2x equals to 6. What is x? It is 6 over 2, it is 3. When you put x here, 2 times 3 is 6. Now, when we say 2x equals to 3, what is x? It is 3 over 2. Because if you multiply 2 by 3 over 2, you will get 2 times over 2, it is 1, and this will be 3. Now, this is rational. Excellent. Now, let me give you one more example. When we have, let's say, x squared equals to 4, what is x?
Plus or minus 2.
Positive or negative 2. When we say x squared equals to 2, what is x?
Plus or minus square root of 2.
Positive or negative square root of 2. Okay. Now, this one, what is it? Is it rational? Is it integer? Is it natural?
Is it?
How to prove that it is irrational? There is a proof, by the way. There is a proof. If you just Google it, how to prove that square root of 2 is not rational. It is so easy to be proved by using the idea of the even and odd ideas. So it is, what I can tell you here, that the square root of 2 does not equals to m over n, where m and n here are integers. It cannot be never ever written as an integer over integer. طيب, is square root of 2, is it, are we invent this for fun, or it exists in the real life? If you have a square, let's say, I tell you, for example, just for example, if you have a square and this is 1, this is 1, this is 1, what will be the diameter of this square? By using the Pythagorean theorem, square root of 2, because it will be the square root of 1 squared plus 1 squared. If you remember the Pythagorean theorem, a squared plus b squared equals to c squared. Okay, so there are for real numbers that they are not rational. They are called irrational. Okay, here we are. These are irrational numbers. So there are also real numbers such that square root of 2 that cannot be expressed as a ratio of integers, and therefore they are called not rational, irrational. Just add IR at the beginning. What is the most famous, well-known irrational number? Pi, the Archimedes number. This pi, shabab, which is the ratio between the circumference of the circle and its diameter, it is irrational number. Okay, let me ask you now a question about pi. You know that I think this is something that you need to tell me it is true or false. Pi equals to 22 over 7. True or false?
Approximately, yes.
I'm saying here equals. It is so easy to show that this is not true. Why? Who can tell me why these are not true? Yes.
It's broken the rule of rational numbers.
Could you explain more?
It can't be defined as a rational number because it's
Yes.
Because irrational numbers, you cannot define it as integer or non-integer.
It is the same as you said, but in a better way. Yes. 22 over 7, ya shabab, is what?
Integer is a fraction.
Is rational. Will pi
is irrational.
irrational? So how something that is rational equals to something that is not rational? It is not logical. Okay. Not only that, please, if you have a mobile or a calculator, please give me the result of 22 over 7. What is 22 over 7? 3.14. It is enough. Now, what is pi? Click on pi. 3.14. Pi.
Here in the phone, so I'm going to find it. It's not equal.
They are not equals, but I just want you to show you. 3.1412.
1, 5.
1 5
9
9,
2
6.
6 5 4.
and so on. So look, ya shabab, the confusion is coming from here because the first 3 digits are the same. But in fact, what is the true? What is the true statement here? That 22/7 is greater than pi. It is more than, this number is greater. Look, 2 is greater than 1. So now this number is greater. Between any two rational numbers, there is a rational number. And between any two rational numbers, there is irrational. And between any two irrationals, there is irrational and there is irrational. And you can go like this forever. So they are micro numbers. Okay. So they are not the same. What is true, if you want to make this, you can say that they are approximately. I heard someone says approximately they are the same, but we are not saying that. We are here to say exactly, are they exactly the same? No, never. طيب, what about the last number here, Shabab? Is it rational? Is it rational number? This one?
Yep. It's 3/4. No.
Is it rational? Yes or no?
No.
Why it is not rational? So when we write 3/pi, this is not rational. Why it is not rational? Because pi is rational or irrational. What about pi/pi? Is it rational?
Yes, equals 1.
Because this is 1. It is just another way to say 1. 1 is rational. This is why this is not rational. This is not rational. Why? Because the rational number, ya shabab, look here what we said. What is rational? Integer over. This is not integer over integer. It is integer over something that is not integer. Okay. Okay. We have many tricks like this. We will see them later. But now let's continue. Now, ya shabab, when we combine the rational number together with the irrational numbers, we will have what is called the real numbers. Let's summarize what we did before. Natural numbers, we started with the natural numbers. The natural numbers can be classified into 2 types: prime, composite. Then we add 0 and the negatives, and then we have integers. So when you add to the natural numbers the 0 and the negative of them, we will have integers. Also, the integers are classified into 2 sets of numbers: even and odd. Then when we divide integer by integer, we have rational number. When we say integer by integer, what is in the denominator shouldn't be 0. This is very important. I will mention this at the end. Now we have also the real numbers that they are not rational, they are irrational. And all of these are the real numbers. I want you to have a look at this and ask yourself, is every natural is integer? Is every integer is natural? If I add, subtract, multiply, divide 2 by 2, what I will get? I will give you like 1 to 2 minutes. During that, I will take the attendance. Now, ya shabab, can you tell me, please, true or false? Every natural number is integer.
No, false.
Give me a natural number that is not integer.
Natural number, yeah. Every natural number is integer.
Every natural number is integer. Good. It is your turn. Every rational number is integer.
No.
Give me one rational number that is not integer.
A half.
A half. You are right. What about the opposite? Every integer number is rational.
Yes.
Is it true?
Yes.
Excellent. Every real number is irrational.
No.
Give me one number that is real number that is not rational. We said every real number is irrational because we have the rational numbers. So the real numbers, if you have rational, it is real, but not irrational, like a half. Okay. And so on, ya shabab. When you add, you can think about it. There are many questions about this. I want to think about these issues. Keep asking yourself, what if is everything add, multiply, divide, is when you add rational to irrational, rational to rational, irrational to, we cannot, of course, explain all of these during the class, but ask yourself about them. It is good to think about them. Great. Now let's continue. We still have like 5 minutes. In these, shabab, there is nothing new, but just just I think we need to hide this. Why? It should go this way. Addition and subtraction, ya shabab. 44 plus 27 is equal to 27 equals to 71. This is called the sum or the total, and this operation, it is called addition. When we a plus 0 equals to a for any real number a. So when we add 0 to any real number, we get 0. This is why we called the 0 the identity of addition. Every real number a has a negative. Any real number, it has a negative. It's negative. If you add any number to its negative, you will get the identity. You will get 0. Negative a, it is called the additive inverse. So the negative is the what? Is the additive inverse. Subtraction is the operation that undoes the addition. So it is the opposite of addition. And then the result of subtraction, it is called what? Difference. The difference. Here. The difference here is 17. Look at the definition of the subtraction, shabab, so important. A minus B. What is A minus B? It is A plus the negative of B. So easy. Now, how to add numbers when they have the same signs? What is that? What is signs? 3, negative 3. This is positive 3. This is negative 3. These are called signs, positive and negative. So now, if you are adding numbers with the same sign, just you will add and keep the sign. Look here. Just add and keep the sign. But if they have different signs, one positive, one negative, you will subtract and keep the sign of the greater number. And this is just for you to have an idea. It is so easy. Negative 3 plus 8 is 5. Negative 50 is plus 18 is negative 32. Here we just take the difference because of the different signs. When you subtract a positive number from a negative number from a positive number, like here, 14 minus negative 4. Indeed, here you have a multiplication. Negative times negative is positive, and you have 14 plus 4 equals to 18. Now, for the multiplication, as I show you at the beginning, 3 times 7 is 21. 3 and 7, they are called the factors of 21. And 21 is called the product of 3 and 7. When you multiply any number by 1, you will have the same number. This is why we called 1 the identity of multiplication. Every real number has, let me remove this. Every real number a has an inverse. What is that inverse? It is 1 over a. That is, if you multiply any real number by its inverse, if you multiply a by 1 over a, you will get what? 1. Except 1a. What is a that this is not true for it? This is not true if a is what? So we should say that a is not 0. This is exactly what they said here. So without this, ya shabab, without this is not true. If they said every real number a has an inverse, it is not true. It is in fact every non-0. And by inverse here, by inverse we mean the multiplicative inverse, not the additive. And there is another name for the multiplicative inverse, the reciprocal or multiplicative inverse. So this is a, this is the reciprocal of a. Now, as we said, a is not 0. A cannot be 0. Why we cannot divide by 0? This is undefined. What is the meaning of that? It means not defined. This means that there is something defined and this is not defined. So what is defined? To know what is not defined. So again, it is undefined. It is not possible. Why? Could you understand? It is clear, Shabab, someone of you, they may say, one of your colleagues in the previous class, they say, how can I give something or divide something over nothing? But someone, they may ask you how to add something to nothing. The same logic. But in fact, there we can do it in the opposite way. How to add something to nothing? It is similar to adding nothing to what? So when you add nothing to something, you will get the same thing that you have before. But for the division, there is something that is related to the definition of the division. You know what is the division? This is division. When you have a over b, A over B equals what يا شباب? C. If what?
If B doesn't equal to
A over B equals to C if what? If C times B is what? Equals to A. And of course, B is not 0. And let me just, will take for like 30 seconds from your time. 12 over 3, what is it?
4.
Why?
Because 4 times 3.
4 times 3 equals to 12. Now, 12 over 0, 0. 12 over 0 is 0. Multiply 0 by 0. Look here, when we multiply 4 by 3, we obtain what? Yes, if we multiply 0 by 0, are we going to have 12? No. Give me any number, if any number, whatever, C مثلا. If you multiply any number by 0, what you will get? 0. If you multiply any number by 0, you will get 0. So it is impossible. It is not consistent with the definition of the division. So this is why we call it undefined. It is not defined when we define the division. We will define the division, inshallah, in the next class, and we will continue doing these